Okay, so we're going to talk today about 8.2, which is union, intersection, and complement of events and odds. So the union of two sets A and B is the set of all elements that belong to either of the sets. The elements are in set A or they're in set B. And a union B is denoted by A union of B. So it's all of A and all of A put together. The intersection of two sets A and B is the set of all elements common to both sets. So the elements are in set A and they're in set B. So the difference is the union is it can be in this set or it can be in this set. The intersection, it has to be in both sets. So think about the intersection of a street. They are on, where it intersects, they're on both streets because it's on this way and this way. But the union is this one or that one. It just has to be in one of them. Intersection has to be in both. All right, so when computing the probability of the union of the two events, it's a common mistake to simply add the probabilities of those two events because some outcomes may be in both events. So you must subtract the intersection of the events. So here is the rule that we'll use for the union. So the probability of the union of event E and F, you'll add the probability of E plus the probability of F, and then you'll subtract where they intersect so that you don't count them twice. And then to compute the probability of the complement is that symbol right there on the E, the apostrophe. So the probability of the complement of E is equal to the 1 minus E. Remember, all of our probabilities add up to 1. So 1 minus what the probability of the event was. Or you can find the probability of the event by subtracting the complement from 1. And then understanding that the probability of E plus the probability of the complement equals to 1. So remember, the probability of an outcome in a sample space is always a number somewhere between 0 and 1. We talked last class that you can't have a probability of a negative number. So they have to be between 0 and 1, and then all of them have to add up to be 1. And that's showing you why this is a true statement up here. So your sample space is going to be S, and for the odds, we'll use E is equal to the probability of the event over 1 minus the probability of the event. Well, that's the same thing as the probability of the event over the complement. And remember that the probability of the event won't be equal to 1 if we're doing this, because then we would get 1 minus 1, which would be equal to 0. Can't divide by 0. The odds against E will be the complement, or the probability of the complement, over the probability of the event. And in this case, P of E, which the probability of the event, can't be equal to 0. All right, so let's look at our first problem. Our card is drawn from a well-shuffled deck of cards. Find the probability that the card is a spade or a 10. So a spade or a 10. So this is 8.2, and we are on example 1. So we're looking at drawing a spade or a 10. So we have to remember a few things about our decks of cards. First of all, we talked about last class, there are 13 of each suit in a deck of cards. So spade is one of the suits. You've got spades, clubs, diamonds, and hearts. Those are the 4 suits. There are 52 cards in each deck. If you divide 52 by 4, you get 13. So there are 13 of each suit in a deck. And then there are some number cards and some face cards. So on the number cards, you've got 1, well, the ace, through 10. I don't know that in some cases we usually don't do probabilities with aces, so we won't have to worry if that's a number card or an ace. But 2 through 10 is definitely a number card, and even the aces would be counted in the same thing we're looking at. There are jacks, queens, and kings. Jacks, queens, and kings are your face cards. So on all of those, the ace all the way up to king, there are 4 total in the deck of each one, because there's one that's a spade, one that's a club, one that's a heart, and one that's a diamond. So if we're looking at the 10s, there's a 10 of hearts, a 10 of diamonds, a 10 of spades, and a 10 of clubs. There are also, half the deck is red and half the deck is black. So the spades and clubs are black and the hearts and diamonds are red. All right, so if we're looking at this, we know that there are 13 spades and there's going to be 4 of the 10s. But we also need to understand that there's 1 spade that is a 10, or 1 10 of spades. So if we're looking at finding out how many of our numbers are, we have the number, because we're asked to find the probability that the card is a spade or a 10. So this would be our number. So the number of spades would be 13. The number of 10s would be 4. So I'm going to kind of write this out using something that we did in last class. So in case you missed last class, this will kind of help you with this. We could do this one of 2 ways. So we've got the number of the 10 union with spades is equal to the number of spades plus the number of 10s minus the number of 10 intersected with spade. So minus the intersection. So we're using the same equation for the probabilities, except I'm finding the numbers. I'm going to show you 2 ways you can work this problem. All right, so this is what we're trying to find is the union. What we do know is the number of spades is 13, the number of 10s is 4, and the number of the intersection is 1. So when we add this up, we get 13 plus 4 is 17 minus 1 is 16. We learned in last class that we can do the probability of E equals the number of E over the number of S. So this is one of those where I'm trying to show you can look at this a couple of ways. So the number of E, the event of the union, would be 16, and our sample space for a deck of cards is 52. We can reduce them both by 4 and we'll end up with 4 over 13. All right, now the other way that we could do the same problem is instead of doing the ends up here, we can do the probabilities, which was the equation we saw on our handout a minute ago. So we'll have the probability of 10 union with spades equals the probability of spades plus the probability of getting a 10 minus the probability of getting a 10 intersected with a spade, or a 10 of spade. All right, so we're still looking for the probability of the union. So the probability of spades, in this case, we know that there are 13 spades out of 52 cards. Plus, the probability of 10 is 4 10s out of 52 cards, minus a 10 of spades, which is 1 out of 52. We add our tops, we add our fractions, so 17 minus 1 would be 16 out of 52, and it still reduces to be 4 out of 13. So you've done both examples, or the same problem, using 2 slightly different methods. So you can kind of choose which way you'd go. If you can understand the probabilities, this is a little bit faster maybe to do, because it's one equation versus doing two. All right, let's go look at example 2. So in example 2, a single card is drawn from a standard 52 card deck. Let S be the event that the card drawn is a spade, and let F be the event that the card drawn is a face card. Find the probability of drawing a spade or a face card. All right, so we have the probability of S union with F, a spade union with a face card. So this will be the probability of S plus the probability of F minus the probability of the intersection of S and F. So we've already discussed that as far as spades go, we're drawing, the probability of drawing a spade would be 13 out of 52. Be the same thing for clubs, hearts, and diamonds. The probability of a face card, there are 3 face cards in each suit. There's a jack, a queen, and a king, and there are 4 suits. So 3 times 4 will get us 12. So there's 12 total face cards and a deck of 52 cards. And we just talked about that there are 3 spades that are face cards. The jack of spades, the queen of spades, and the king of spades. All right, so 13 plus 12 will get us 25, minus 3 will get us 22 over 52. That'll reduce by 2, they're both even, and that'll get us 11 out of 26. All right, let's go to example 3. So in example 3, it says, in a lottery game, a single ball is drawn at random from a container that contains 25 identical balls, numbered 1 through 25. Find the probability that the number drawn is even or a multiple of 10. So we're drawing out of 25 identical balls, 1 through 25, we want to know what's even or a multiple of 10. So we're looking at the numbers 1 through 25. So what I need to do is figure out what are the evens. Starting with 1, 1's not even. But we would have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and that would be it, right? Because 25 would get us an odd number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the number of our, we'll call it event A, which is even, is equal to 12. Now we need to find the multiple of 10. So for the multiple of 10, we can look up here, because 10 is going to be an even number. We would have 10 and we would have 20. So that kind of made it easy. Or we can just count by 10s. 10, 20, and 30 would be out of it. So the number of our event B would be equal to 2. And in order to look at what we're doing, we'll go look at our equation here. So we are looking at the probability of the union of B, A and B, equals the probability of A plus the probability of B minus the probability of A intersect B. Now, you don't have to use A and B. You could have used even, you could have used E, and you could have used a T for 10, or E and an M. It doesn't matter what letters you choose in here. Formula is going to be the same. All right, so the probability of A is going to be 12 out of how many balls did we have to draw? Because this is 12, that's the number of the event. We had 25 to draw from, so 12 out of 25. The probability of getting a multiple of 10 was 2 out of 25. And then how many are in the intersection? Well, the intersection means it's in the evens and it was a multiple of 10. Well, 10 and 20 were in our intersection here, or in our set of even, so it's going to be 2 of them. So we also understand that the number of A intersected with B is also equal to 2. So minus 2 out of 25. Well, you can kind of see these will both cancel out. We are left with 12 out of 25. Now, pay attention in your homework because they might be looking for a decimal. So you could then turn 12 out of 25. You can put that in your calculator as a fraction. And you get 0.48. So just type it in as a fraction and you'll be good. Or just 12 divided by 25. So you might also, so pay attention in the homework if they're looking for a decimal answer or they're looking for a fraction. Also pay attention, you're going to need some notes on these. Some of the ways that they're working the examples are not quite the way we're doing it, so it might be confusing in there. All right, so example 4, we are looking at an experiment consists of drawing one card from a standard 52 card deck. Let E be the event that the card drawn is an ace of spades. Find the probability of the complement. So remember the complement is going to be 1 minus the event. All right, so we're looking at the probability of drawing an ace of spades. All right, so for this one, we need to understand how many ace of spades are there. There's only going to be one. So the number of the event will be equal to 1 because there's only one ace of spades. And then the sample space is equal to 52. And so we are going to find the complement. So looking for the complement, we can do the fact that we've got to find the probabilities here, or use the probabilities. So if we're looking at the number, is going to be 1 out of 52. So remember, and you could do this a couple of ways. You could find, again, there's several times there's a couple of ways we can do this. We can do the probability of the complement is equal to the number of the complement over the number of the sample space. So if there's only one in the event, you would find the number of the complement would be equal to 52, because there's 52 cards, minus 1 card, that was the event, which will get you 51. So we can do it this way. We would then get the number of the complement is 51 out of 52, and that would be your answer. Or you could look at that probability of the event, like we saw on our formula, equals 1 minus the probability of E. So then this would be equal to 1 minus our probability is going to be 1 out of 52, because it's got to be the event over the sample space. So this would become 52 over 52 minus 1 over 52 equals 51 over 52. So again, there's a couple of ways you can work some of these problems. You don't have to work them exactly one way or the other, as long as it coincides with what we're actually doing. All right, so for example 5, if the probability is 0.81 that a candidate wins the election, what is the probability that he loses? Well, in this case, we're going to do the equation that we did here. So the fact that he's losing would be the complement, because they gave us the probability of winning. So the probability that he loses would be the complement. So it'll be 1 minus the probability of the fact that he won. So this will be 1 minus 0.81, which will get you 0.19. So that one's a little bit shorter. All right, let's go on to number 6. So for number 6, we have a single card is drawn from a standard 52 card deck. Let B be the event that the card drawn is black card, and let A be the event that the card drawn is an ace card. Find the probability of the black card intersected with the complement of A. So that's where we've got a little bit going on here. All right. So first of all, we have to find a couple of things. We need to find, we're looking for the probability, and this is example 6, of black card intersected with the complement of A. So we've got to find a couple of things. So we're looking for a black card that is not an ace. That's what that means. If it's the intersection between a black and an ace, then it's black aces, right? But in this case, it's black cards that are not an ace. That would be the complement. So we're going to look at the probability. Let's find the number of cards that would be black intersected with a complement. So this would be the number of black cards minus the number of black cards that are aces, because we're looking for the not aces. So the number of black cards would be like our 1, and the number of black aces would be the event. So there are 26 black cards. Oh, no, there's not. Oh, yes, there are. Sorry. For a moment there. I'm thinking spades because we've done a lot of spades. So black cards would be spades and clubs. So 26. And of those black cards with aces, there are 2. There is an ace of clubs and an ace of spades. So this will be equal to 24. So now we're looking at the probability of the intersection of the complement. This will be equal to the number of B intersected with a complement over the number of S. So we found this part here. That's going to be 24. And the sample space is always going to be an entire deck of cards. So that'll be 52. And they will reduce both by 4, and we'll end up with 6 out of 13. Okay. All right, let's go look at number 7. So for number 7, we have a pair of dice that are rolled 1,000 times with the following frequencies of outcomes. So here's the list of frequency of outcomes. We're going to use those to calculate the approximate probabilities and odds for the event. So we're looking for the sum is less than 5 or greater than 8. So less than 5, so not equal to 5, but less than 5, and greater than 8. That means not equal to 8, but greater than 8. So let's go make some lesson. For the video, I don't know how easily it is to see those numbers, but I will help you out. And if you're in my class, you have the handout. So first of all, we're looking for the number that are less than 5, and we're going to call that event A. So on the less than 5, and we're looking for using the frequencies to calculate. So this is the sum on top, the frequencies on the bottom. So less than 5 would get us the sum of 2, 3, and 4. We're going to add the frequencies. We have a 10, a 30, and a 60. So the number of A will be 10 plus 30 plus 60, which will get us a total of 100. Now we need to find the number of those that are greater than 8, and we're going to call that B. So greater than 8, so not equal to 8, we've got 9, 10, 11, and 12. Our frequencies are 120, 90, 40, and 20. So 120 plus 90 plus 40 plus 20 equals 270. And then the number of A intersected with B, so where do these intersect? They don't intersect at all because one is down here and one is up here. So there is no intersection between them, so that will be equal to 0. So using our probability formula, the probability of A union with B will be equal to, and there are a total, they told us there was 1,000 rolls. A pair of dice are rolled 1,000 times, so that's our sample space. So it'll be equal to the 100 for our, first I got to do the probability of A, so sorry. So the probability of A plus the probability of B minus the probability of the intersection. All right, so 100 out of 1,000 plus 270 out of 1,000 minus 0 out of 1,000. Well, this will get us 370 out of 1,000, and that will reduce, you can reduce the end zeros when they both end in 0, and you get 37 out of 100, and that would be your answer. Now, for that part. Now, what they asked for is we're looking for the probabilities and the odds for the event. So the odds of the event are going to be the probability over 1 minus the event, or the probability of the event. So our odds of the probability of A union with B will be equal to the probability of A union with B over 1 minus the probability of A union with B. So this is going to get a little like messy in the, there's going to be some fractions here. All right, so we will have 37 out of 100, because that's our probability of A, divided by 1 minus 37 out of 100. So this will get us 37 out of 100 over, this will be 100 over 100, minus 37 over 100. So that'll get us 37 over 100 divided by 63 over 100. We don't divide by fractions, we multiply by reciprocals. So we would have 37 over 100 times 100 over 63. The 100s will cancel, and we're left with 37 over 63. So that's the odds of the probability. Probability, odds of the probability. All right, next example. Oh, sorry, that was part A. This was all part A. And I didn't write part A at the beginning, so I'm going to tack that in there. So that's part A. Now we'll go to part B. So for part B, it said the sum is even or exactly divisible by 5. So if it's divisible by 5, it's going to be a multiple of 5. And the sum is even. That means we're going to do the even numbers like 2, 4, 6, 8, 10, and 12. And divisible by 5 will be 5 and 10. All right, so we've got the number of the even, and we're going to call that n of a, and then the number of divisible by 5 equals the n of b, and then remember we have to have the intersection of a intersected with b. All right, so if we're looking for the sum is even, that'll be for 2, so that'll be 10. 4 would get us 60. 6 gets us 110. 8 is 170. 10 is 90. And 12 is 20. So that means we're going to add 10 plus 60 plus 110 plus 170 plus 90 plus 20. And that'll get us a total of 460. Now, for the multiples of 5, or things that are divisible by 5, we'll get 5 and 10, and that'll be 190, which will get us 190. So I'm going to kind of box our numbers so we can track, because we've got a big list. Now we're looking for the intersection. Well, when we were looking at the even numbers and then the multiples of 5, the multiple of 5 only have 2. The only one that intersects is when we had 10. It's an even number and it's a multiple of 5, which will be equal to 90. So that will be where we have our intersection. All right, so now we have the probability of A union with B will be equal to the probability of A plus the probability of B minus the probability of A intersected with B. So the probability of A was 460 out of 1,000 again, like we did on the previous problem, plus the probability of B is 190 out of 1,000, minus the intersection is 90 out of 1,000. If we add those together, we end up with 560 out of 1,000. And then we need to reduce it. So we could start off reducing it with the zeros. That'll get us to 56 over 100. They are both still even. So we can reduce that again to be 28 out of 50. And they're still even. So 28 out of 50 will reduce down to 14 out of 25. So if you don't see that they're automatically divisible by something, if you can reduce the tens or the zeros, and then if you can, if they're even, just keep dividing. All right, so that's our first part. Now we got to find the odds. The odds of the probability of the union. All right, so this will be equal to the probability of the union divided by 1 minus the probability of the union. So the probability of the union is 14 out of 25, and then 1 minus 14 out of 25, which gets us 14 out of 25 over 25 over 25 minus 14 out of 25. You don't have to show me this stuff. I just want you to know where the numbers are coming from, especially since we're not in class today. So 25 minus 14 will get us 11 out of 25. Again, we don't divide by fractions. We multiply by reciprocals. So 14 out of 25 times 25 out of 11. The 25s will cancel each other, and we're left with 14 out of 11. All right, our next problem is problem number 8. So for example 8, we are examining the past driving records of drivers in a certain city. An insurance company has determined the following probabilities. So they're listed here with accident, no accident, some totals, less than 10,000, 10,000 to 15,000, more than 15,000. We've got some totals here and some totals down here. Now, if a driver, part A, if a driver in the city is selected at random, what is the probability that he or she drives less than 10,000 miles per year or has an accident? So the or part tells us this will be a union. If it was and, it will be an intersection, but we're looking for a union. So we're looking at less than 10,000 or an accident. So let's write that down. So for part A, we're looking for less than 10,000 or an accident. So we can keep track of what we're looking for. Now we're going to use our chart. So if we're looking at the probability of less than 10,000, this is right here, less than 10,000, we can add these. We could go through the work of adding them, but they've already given us the total. So the total for less than 10,000 is 0.15. So the probability of less than 10,000, we're going to call probability of A, and it's 0.15. The next one will be the probability of an accident, and we're going to call that the probability of B. So the probability of an accident goes across the row, and they already give us the total of 0.50. So we're just following the accident across. So it'll be equal to 0.50. Now I'm adding that 0 at the end so that we have the same number of decimal places, and I like to put the 0 in front, but you don't have to. Now, whenever we're doing this, we're going to have to find the probability of A intersected with B. So where do they intersect? They'll intersect with less than 10,000 and accident. So less than 10,000 goes this way, accident goes that way. Where do they meet? Right there at 0.05. It's in both the row and the column. So that'll be equal to 0.05. So now we can find the probability of our union will be equal to the probability of A plus the probability of B minus the intersection of A and B. So the probability of A is 0.15 plus the probability of B is 0.50 minus our intersection of 0.05. And that will get us a total of 0.60. All right, now part B. Part B asks us, if the driver in this city is selected at random, what is the probability that he or she drives 10,000 or more miles per year and has no accidents? 10,000 or more and has no accidents. So greater than 10,000 and no accidents. So we've got two parts here where they go 10,000 or more. So this is 10,000 or more, and so is this one. We've got 10 to 15,000 and 15 or more. So there's two parts right here, and we're looking at and no accidents, right? So and no accidents. Now remember, and is your intersection. So where do they intersect? Well, they intersect with no accident and those 10,000 or more. So we're going to have to add both of these numbers together. So for part B, we are looking at the probability of A intersected with B And it would be 0.15 plus 0.25 equals 0.40. And that's coming from those two numbers of 0.15 and 0.25 in the greater than 10,000 intersected with no accidents. All right, so now we're going to go on to our next example, example 9. So for example 9, we are looking at a shipment of 40 inexpensive digital watches, including 11 that are defective. It's sent to a department store. The receiving department selects 10 at random for testing and rejects the whole shipment if one or more in the sample are found defective. What is the probability that the shipment will be rejected? All right, so, and remember, once you choose a watch without replacement, the number of watches to choose from will decrease each time. Now, when you do this type of problem in your homework, the way that they're doing it is not the way we're going to do it, because we're not covering permutations and combinations, which you could do it with that, but we're not doing that in this course because we don't have enough time with all the other things that we're doing. So I'm going to show you how to do this without doing what they said. All right, so we are looking at a couple of things here. So we've got, let's look at the question one more time. A shipment of 40 inexpensive digital watches, that means we have a total of 40, including 11 that are defective, is sent to a department store, and the receiving department selects 10 at random for testing and rejects the whole shipment if one or more in the sample are found defective. So once they found a defective one, they aren't. We want to know what's the probability that it's going to be rejected. All right, so again, we had a total of 40. And we're told that there are 11 defective. And we want to select 10 of those. And we're trying to find out, will it be rejected? Okay? So, for our E, the E is going to be one or more watches is found defective. And we know that that is a total of 11 because we have an 11 defective written right there. So the E complement will be no watch is found defective, or no watch found is defective, however you want to write it. All right. Now to find that, we have a total of 40. If we subtract the 11 defective, that means that there are 29 that are not defective that are in the shipment. And just so we understand, our S is going to be 40. That's our total. All right, so we are going to do this without using the combinations or permutations, like I said in the homework. So what I'm going to show you is that we're finding the probability of our complement, not a defective watch, will be equal to the number of not defective over the number of the total. Now we're going to draw out 10 watches. When we draw on the first watch, we have a total of non-defective watches to choose from is 29 out of the total of watches, which is 40. When we draw the second time, we took that watch, so we've got all these watches, right? We took one watch out, so now we have one less watch. So we're putting them out without replacement. So that means now there's only 28 non-defective watches to choose from out of 39 watches. On the third one, we'll have 27 out of 38. On the fourth one, it'll be 26 out of 37. On the fifth one, we'll have 25 out of 36. On the 6th watch, we'll have 24 out of 35. On the 7th watch, we'll have 23 out of 34. On the 8th watch, we'll have 22 out of 33. On the 9th watch, we will have 21 out of 32. And on the 10th watch, we will have 20 out of 31. Now what we're going to do with all of these numbers is we're going to multiply them. And I investigated a couple of ways to do these. If you do the top and then try to divide by the bottom, it gets you, it gives you scientific notation in the calculator. So what I want you to do is I want you to multiply the top inside parentheses and then divide by the bottom inside parentheses. And if you do that, it'll just give you a straight answer of 0.02. And then you don't have to try and put that big old number divided by the big old bottom number. Okay? And this is the probability that no defective watch is found. Okay? 0.02. All right, now we are looking for the probability that it's rejected. This would mean it's not rejected because that's what our no defective watch is found. So that would be the probability that we don't find a defective watch. But we're looking to see about the rejecting. So we're going to use the probability of E is equal to the 1 minus the probability of a complement. So this will be equal to 1 minus 0.02, which will get us 0.98. And that's the probability that a defective watch is found, which will reject the shipment. Okay? So this is the probability that the shipment is rejected. And that is the end of 8.2.